Hi, my name is John Heeter, and I'm the founder at Boyd. And I'm going to talk about on-chain governance because it's something that we've been researching a lot recently to deploy our governance solution with the Boyd token. So, what is on-chain governance? Actually, it's pretty simple. It's just multi-sigs. It's just multi-sigs all the way down. You have multi-sigs that control on-chain actions, and the governance model is responsible for determining who's on that multisig. And the names that you see here on this multisig, which is the Yostack multisig, these represent people, but they also could represent groups of individuals, like multisigs inside of multisigs, and they could also represent smart contracts that are responsible for things. So Yostack is probably the most common DAC structure that you've seen on USIO blockchains, because it was the first. And it's broken up into kind of three main modules. So you have contracts, the backend, and the interface. The contracts cover everything from voting for custodians, determining the authority of the multisigs, escrow, and there's some new kind of proposals and referendum functionality that's coming online soon. For the back end, it's actually pretty complicated because you need to track some kind of history information in order to fill in the UI. So, and also there's like a WebSocket API as well. So I would say, yeah, the backend is fairly complex. And then the interface is actually very good. It's built with a Quasar language with Vue.js, and it's responsive, it's themable. So that means that it's easy to kind of add your own pages, theme it however you want, and kind of extend it for all kinds of different use cases. So there's three major kind of implementations of the Yostack technology stack. There's the original Yostack, which is based on around 12 custodians and with 5 votes per token. And then you have the DAC factory, which is basically an easy way to deploy your own version of Yostack with customizable parameters. You can set the number of custodians, you can set the number of votes, things like that. And then Vigor DAC is actually kind of the most custom version of this contracts. They actually forked Yostack. They have 21 custodians, and their candidates are paid based on their vote rank. So that's right, not just the custodians, but the candidates are also paid. And also there's kind of a confusing component where the VIG that is tradable that most people own is not the same VIG which is used to vote on the DAC. The VIG that is used for voting is highly controlled by the custodians. And also the custodians are the only ones that can vote on candidates. So there's a lot of Sybil resistant functionality built into the Vigor DAC, and they're planning on removing some of those limitations in the future as they're able to test things and make the system more robust. The next common kind of on-chain governance structure is Telos Decide, which is used for the Telos worker proposal system mostly, but it's also kind of extendable and deployable for any use case. So it's based on contracts, like there's a committee, ballot, treasury, there's a voter contract and a worker contract. So what's interesting about workers in the Telos Decide ecosystem is that workers are responsible for kind of doing the kind of accounting and CPU work. So the individuals that are voting don't have to pay very high CPU costs in order to participate. The interface, there's a few interfaces for Telos Decide. The best one would be Chain Inspector, which is used for the worker proposal system. The newest one is the app.telos.net, and then there's also like the HYPA/Seeds DAO Passport interface. And so so I just mentioned these are the WPS and Seeds are the most common implementations of Telos Decide. And you have some pretty good functionality, like you vote with Telos, you pay a submission fee for the WPS, and then you can kind of claim if you were voted in. The Seeds DAO is I would call it very ambitious. They have a lot of plans, and they have this kind of reputation system where it's not just about how many tokens you hold, but it's also kind of about activities that you've done in the platform that determines your vote weight. But in my experience, their solution is still fairly pre-alpha, and it's hard to say whether it's right or wrong or correct implementation, because it's just all the components are not quite there yet. So to compare Yostack and Telos Decide, I would say that the Yostack has a great UI that's easy to extend. It has new modules that are constantly being worked on and coming online soon. It has a vote weight functionality built into the token voting structure, which basically means that you can customize how the token weighted vote works with some data from an external contract. The disadvantages of Yostack is that it's custodian-based voting only, so there's no kind of idea of like a liquid democracy, and there's a very complex structure required to self-deploy, so that places a lot of reliance on utilizing the DAC factory, unless you're very technically competent. So Telos Decide has modular voting mechanics, so they actually have like 5 different voting systems that you can implement that are built in, that you can choose when you set up Telos Decide. It's maintained at the system level, so that means that like the block producers and the core Telos team maintain these contracts, so you don't have to worry about deploying them yourself, and it doesn't require any backend services. However, if you want to build an advanced UI, you probably would need to roll your own backend service. There's only kind of basic UI implementations. There's not like a reference implementation for Telos Decide, so you kind of have to figure it out on your own if you want to build a UI. And there's no kind of a vote weight mechanism, so it's basically all of the voting has to do with how many tokens you hold, basically. And there's no way to kind of decay your vote weight or modify your vote weight. So I'd say that this is, a missing feature that should be implemented for more flexibility when using the Telos Decide system. Here's a video from Vitalik about potential issues with on-chain voting mechanics.
So if you look at EOS has these 21 delegate slots. And to get into one of these delegate slots, you have to basically vote, or you have to have people with enough coins vote for you, right? Now, in total, about 17% of the EOS holders have voted at all. And out of those, the delegate that has the largest number of votes is Bitfinex. And Bitfinex only has about 3.5% or so of all the ETH voting for it. Out of that 3.5%, 1.8% is coins that are owned by Bitfinex themselves. And the other 1.7% is just random people. So with that 1.8%, Bitfinex was basically able to single-handedly get themselves into this list of 21 delegates when they otherwise would not have been able to get in there. And what this privilege gives them is it basically gives them the ability to take a share of the 1% a year annual interest that's allocated to Bitfinex or that's allocated to EOS delegates. So basically, what this voting mechanism has created is it creates this kind of superlinear pro-plutocratic effect where if you're big enough, then, and specifically if you're big enough to have more than 1.8% of all the coins, you have enough votes that you can use to basically buy up a delegate slot and then use that delegate slot to earn even more money and get access to this crazy special 2.64% extra premium interest rate that no one else has access to.
And then here's some solutions that we are kind of in the process of. We're kind of in the process of implementing some of these solutions for our own kind of custom governance structure. Unique ID helps to protect the kind of voting power of individuals, but obviously the KYC can become a central point of failure, and it doesn't solve all problems, and it actually could cause more problems. Stake bonds is interesting. Dan proposed that last year for solving governance issues on the mainnet. Basically, the longer you vote, essentially the longer you vote, longer that you lock up your tokens, the higher vote weight that those tokens will hold. Proof of work, basically this idea that your tokens don't have any power unless they're backed by something, some kind of expenditure of energy. And quartiles, basically you break your community into many groups. And then each one of those groups has like a Pareto distribution inside of it. And this helps to make sure that a larger variety of individuals in your community can have a voice. Any questions?